Hello everyone. So today we are going to see the solution to the coin change problem. This is a dynamic programming based solution and it's a pretty popular one. So let's jump right to the problem statement and try to understand what it is trying to say. So it says that you are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, then return -1. And you also have to assume that you have an infinite number of coins of each kind. So let's try to take an example. They have also provided us with a few examples. So for example, they gave us denominations 1, 2, and 5 and an amount 11. So basically, there are many ways by which you can make up this amount, but basically they want us to give us the solution which we can get by using minimum number of coins. So that will be 3, which in the explanation is also pretty clear, which is you can take one coin of 5 denomination, then another of 5 denomination, and then another last coin of 1 denomination. So 5 plus 5 plus 5, 1 will be your answer, which is 11. Uh, but basically there can be other combinations also, like for example you can also take 2 2 2 2 5 times 2 then 1. This will also be 11, or you can say 2 comma 2 comma 3 comma 3 then 1. This will also be 11, but here in this case this will cost you 6 coins and this will cost you 5 coins, so our solution should be this one. So basically if we try to look at this closely, we can see that this can be easily solved via dynamic programming. I'll try to explain how that is happening. So let's first of all try to forget about dynamic programming or anything else. Let's try to see how we would have solved for this 11 amount. And our coins are this one, 1, 2, and 5. So like if we don't know anything how to go about this is, we will try to take a coin of one denomination. Then I have taken one coin, and then I will try to see how much coins will be needed for making 10. Or my other choice could have been I could have taken a coin of two denomination, and then I would have tried to find out how many coins we will need for 9. Then my last option would be I would take the coin of 5 denomination, and then I will try to find out how many coins are needed for 6 amount. So basically these three are my choices from these denominations, and out of these I don't know which one is going to be beneficial for me the most. So what I'm going to do, I'm going to try all of them, and out of them whichever is the minimum will be my overall solution. So basically, because right now it may seem that we are taking a bigger number, so this will always, lead to a smaller, like our final solution. But that is not the case. It may be possible that by taking 2 in the first iteration, we may be getting the final overall result, which would be our final, minimum number of coins. But that is not always the case. It can come from any of the ways which we don't know. That is why we will have to try each and every one of them, and then take the minimum of whatever all the possible choices that we have, and that will be our final result. So let's try to see what should like a couple of base cases and when this thing is finally going to end, and how our dp table is going to look like. So our dp table will just be like 1D array, and for this the ith element will represent minimum coins needed for I amount. So now we will basically be just be running two nested loops. One will be for our target, which we will try to build this up in a bottom up manner. And in the bottom up fashion, when we are going about this, we will basically for each dp of I, what we are going to do, we will go to each coin and try to do this minimum of 1 plus dp of I minus coin, which will be, first of all, it will be coin 1, then it will be 1 plus dp of I minus coin 2, and so on and so forth. whatever number of coins there might be possible. But a couple of things that we will need to keep in mind here is, so this thing, since this is an like index that we are accessing, so we will have to make sure that whichever coin that we are currently taking, coin should be greater than or equal to the current amount. This is the one thing that we will have to keep in mind. And the other thing is, what should be the value of our starting index. So basically, when you don't have any amount, so the number of coins needed is also zero. So we will initialize this with zero. So let's try to jump to the code and see how this is working out. It will make more sense then. So first of all, this is our signature that has been provided to us. So we are going to go ahead and initialize a DP array, and its size will be amount plus one. Why this is plus one? Because we need to somehow start from the zeroth index, and we will be initializing this with zero. Now what we will do, also, yeah, this there is another thing, that if any combination is not able to make up that given total, we need to return minus one. So we will need to take care of this thing also. So here we will be writing our main logic, and in the end we will be returning dp of amount, because as I said, that dp of I will is denotes that how many minimum number of coins are needed for the ith amount, and our target is to find the minimum number of coins for this amount variable. So in the end we will be returning dp of amount. So now let's say that our I is basically the current amount that I am considering. It will start from 1 and it will go until amount. And here for each I will need to consider each and every coin that is available. And we will be putting the conditions, uh, necessary conditions, so that we are not violating any index values. So in the end, we need to be, in this step, we will need to populate dp of I somehow. So let's now try to see how this will happen. So let's initialize a variable current, which will denote how many number of coins will be needed for I amount. So I am initializing this with, let's say, we can initialize this with infinity. This is just for denotion, like, I mean, just to denote that we currently have not calculated anything. Then we will go to each and every coin, try to include that coin if possible. So what we need to ensure is that if coins of j is should be less than or equal to I, and also that amount should be possible. So I'll explain this condition in detail. So first condition would be more or less clear, that this is the jth coin we are considering for I amount. So it is mandatory obviously that this value should be at least either less than or equal to the current amount. Otherwise you can't consider a coin of value 10 for an amount 5. This is basically that condition. And the second condition basically means that whichever coin you are considering, after taking that coin, the remaining amount should also be possible to be generated. So basically, in the problem statement also it says that if it is not possible to create that combination, just return a minus one. So some values in our dp table will be minus one, which are not basically, which cannot be generated by any given combination. So this second condition is going to eliminate those branches. So if this is the case, then what we are going to do, we are going to see whichever is minimum is my current. And if I consider the current coin, then I have already taken one coin, so I will add 1 plus dp of I minus coins of j. So whichever is minimum, I will consider that. And in the end, I need to, now after this loop, I have considered all the basically here, this is the this iteration we have completed. We have considered each and every coin. Now in the end, my current variable will be holding whichever is the minimum number of coins needed for this ith amount. But it might be possible that basically neither of the combinations, like no, by considering any of the coins, this I amount cannot be generated. So in that case, basically this current will still be holding this value, which is integer dot max value, which we have initialized it with. So we just need to take care of that thing. So if current is still equal to positive infinity, then it means that ith I amount cannot be generated, so we will put a -1. Otherwise we will put whatever has been calculated so far. So yeah, this should be more or less okay. Let's just double check once if we have missed anything or something like that. So let's try to run this. So basic cases are getting accepted for 1, 2, and 5. Amount 11, our output is 3 and expected is also 3. Then in case of 2, the amount is 3. There is only one coin of 2 denomination, expected amount is 3. So it cannot be generated by any way whatsoever you may try, it cannot be generated. So we will be returning -1. Then there is one more. Okay, yeah. So there is one coin with one denomination, but they want us to generate an amount of 0. So it will require 0 basically coins, which is our base condition. So yeah, this should be fine. Let's try to submit this and see. So yeah, this gets accepted. All test cases are passing. So thanks for watching the video. We'll see you in the next one.